So this week we're going to focus on predicting the amount of product formed in a chemical reaction. And you actually already know everything you need to know to do this. The important thing though is to remember the proper steps. So we're going to start with a little bit of review. So the first thing we need to review is something called the mole ratio. And if you go back to the last time I saw you guys, we have a balanced chemical equation. And let's just do a very, very simple one. We'll do the reaction for the creation of water. So we have hydrogen gas, that's a gas. We have oxygen gas that it reacts with, also a gas. And it's going to create water. And this is a synthesis equation. This is liquid water. However, this isn't balanced at a balance. We're going to put a 2 here. And we're going to put a 2 here. And now it is balanced. And so let's remember what this means. This means that in order to make 2 molecules of water, you're actually going to need 2 molecules of H2 for every 1 molecule of oxygen gas. And so there's my 1 molecule of oxygen gas, and that's going to give me 2 molecules of water that are going to look something like this. Notice no atoms were created nor destroyed. And that's pretty much what the mole ratio tells you. Remember that if I have 2 atoms of hydrogen, I have 2 molecules of hydrogen gas, I need 1 molecule of oxygen gas, and I'll get 2 molecules of water. Same thing as if I have 2 moles of hydrogen gas, that means I'll need 1 mole of oxygen gas to make 2 moles of water. And if I need 4 moles of hydrogen, if I have 4 moles of hydrogen gas, I'll need 2 moles of oxygen gas to get 4 moles of water. And we talked about doing problems like this, so let's take a step and look at this problem on the next page. So of course we don't have perfect amounts of things, so we'll say if we have 6.37 moles of hydrogen gas and excess oxygen gas, we'll talk about what that means later, how many moles of water will be formed? So of course we're always going to start with a balanced equation, which in this case is 2H2 plus O2 gives me 2H2O. And we take our starting thing, we start with 6.37 moles of hydrogen gas. We multiply it by our mole ratio. We're trying to convert moles of hydrogen gas into moles of water. And you guys have already seen this in stoichiometry. And we take our coefficients and plug them in. Remember, write your units first. It'll save you. 2 over 2 is 1. Remember, the sig fig here is infinite, so we have 3 sig fig. So our answer is simply going to be 6.37 moles of water. And that's a pretty simple answer, but all you really need to know is these coefficients, the 2, the missing 1, and the 2, these tell you the mole ratio in the equation. And we saw this already. The other thing that you need to do these problems is you need to understand molar mass. And we learned this last week or 2 weeks ago. So remember that the molar mass of 1 mole of anything is equal to the mass in grams from the periodic table. So for example, if I were to look at the molar mass of H2, I know that this is, I'll put a colon here, 2 H atoms, 2 times H. If I look up H in the table, it's 2 times 1.00794. So the molar mass, or the mass of 1 mole of H2, is equal to 2.01588. Or the molar mass of O2 is 2 oxygen atoms times O. It's 2 times, 15.9994, which is equal to 31.9988. These are both grams. Or if I look at the molar mass of water, this is 2 times hydrogen. So this is 2 times 1.00794, which we already know is 2.01588 grams, plus 1 times oxygen, because there's only 1 oxygen here. It's 1 times 15.9994, which is 15.9994. If I add these two together, what I get is, I get 18.01528, or 0.153. And that's the whole idea of molar mass. And so putting these two things together, we can actually predict the products of things. So let's do an example problem. So I have this balanced equation at the top, and it says 2 iron solid reacts with 3 molecules of sulfuric acid, H2SO4, to give me 1 molecule of iron 3 sulfate and 3 molecules of hydrogen gas. And I'll underline these coefficients so we see them. A 2, a 3, there's nothing there, so that's a 1 and a 3, because we'll need these later. So what we're going to do first is we're actually going to do the first step. And the first step is a little tricky. So we're trying to figure out how many grams of hydrogen gas are produced. The problem is, if you remember these numbers, and I'm going to highlight them in yellow for you, these numbers are not the gram ratio. These numbers are the mole ratio. So our first step is actually to go from grams to moles. So our step 1 is to put our starting thing into moles. So we have 91.60 grams of iron. It's the only thing we're given to start with. So right here I have 91.60 grams of iron. And I know that what that's going to do is, if I go to my periodic table, I know that if I want to convert grams to moles, I look up on the table and I see that 1 mole of iron is the same thing as 55.845 grams of iron. And that's from the table. When I solve that out, I get 1.640 moles of iron. And I left that at 4 sig fig because it's 4 sig fig over here. Now I can use the mole ratio. I know that if I have 1.640 moles of iron, and my equation tells me that if I have moles of iron, I can convert it to moles of hydrogen gas in a simple 2 to 3 ratio. Remember, these numbers are coming from up here with the coefficients. That for every 1.640 moles of iron, I'm going to get 2.460 moles of hydrogen gas. Finally, the last step is to go back from moles of hydrogen gas to grams of hydrogen gas, because that's what the question's asking for. So if I have made 2.460 grams of hydrogen gas, then I can go back and I go to my periodic table, and I know that if I want to go from moles of H2 to grams of H2, for every 1 mole of H2, it's going to have a mass of 2.01588. Remember, it's 2 atoms of hydrogen. And when I multiply that all out, I get 4.959 grams of hydrogen gas, which doesn't seem like a whole lot. So if I start with 91.60 grams of iron, I'm only going to get 4.959 grams of hydrogen gas. And this is what it tells you. So these are big multi-step problems, but this is known as something called gram-to-gram stoichiometry. That's actually one of the most difficult things we do in chemistry because it's multiple steps. So it's gram-to-gram stoichiometry. Step 1, convert grams to moles. Step 2 is use the mole ratio. And then step 3, go back to grams from moles. And this can be used for other things too. You could also have volume in here or molecules on here. We often like to draw something called mole island. And let me show you what that is. So you can imagine mole island as a beautiful little island that's got a mole on it. And to get anywhere in stoichiometry, you have to go to mole island. So if we start with grams, to get to mole island, you have to use the molar mass. And to get there, in order to go grams to mole, you divide by molar mass. And to get back from moles to grams, you multiply by molar mass. So the way you get there is molar mass. You could also go to volume. So volume is another location you can get from mole island. If you want to get off of mole island, you divide. If you want to get to mole island, you multiply. And this time it's that magic number of 22.4 liters at what we call STP. And we can also go to the land of molecules. Once again, to get on mole island, you divide. To get off of mole island, you multiply, and this time it's Avogadro's number of 6.022 times 10 to the 23. And so that's how we get back and forth from mole island. So let's try one more of these problems, and there's a few in the notes to help you with it, but we're going to do one more, and we're going to do it right now. So here we have a Haber process problem for the creation of ammonia from nitrogen and hydrogen gases. And in this case, it says 50 grams of nitrogen gas reacts in a laboratory with excess hydrogen gas to create liquid ammonia. How much ammonia is produced? So remember, step one, we're going to take what we start with and go from grams to moles. So in this case, we have 50.0 grams of nitrogen gas, and we want to get from grams of nitrogen gas to moles of nitrogen gas. And I know that for every 1 mole of nitrogen gas, I have 28.0134 grams of N2. If you're wondering where that comes from, it's because 1N is 14.0067 and N2 has 2 of them. When I multiply that out, I get 1.78 moles of nitrogen gas. So now I can use the mole ratio from the balanced equation. I have 1.78 moles of nitrogen gas. I know that for my equation, if I want to go from moles of nitrogen gas to moles of ammonia, it's a 1 to 2 ratio. 1.78 times 2 is going to give me 3.56 moles of ammonia. And finally, my very last step is to go from 3.56 moles of ammonia, and I've got to turn moles of ammonia back into grams of ammonia. Notice how my fraction is the opposite of the top one. And for every 1 mole of ammonia, I get 17.03052 grams. And when I multiply that by 3.56, I get a final answer of 60.6 grams of ammonia. So lots of chance for you to practice, but this is how you do it. As always, I'm around on Monday and Wednesday from 12:10 to 12:40 for you to get help.